7.3 Compound Events. When we have a compound event, that's a situation where we're going to choose one thing, and then after we choose one thing, we're going to choose another thing. So we're going to choose the sandwich, and we need to first select what kind of bread we're going to have, and then we need to select what type of meat we're going to have. When we have all these different choices, we have a large sample space. We have a large amount of possible outcomes. Okay, so we're going to use a tree method to first figure out what are all our possible outcomes. What is our sample space? So we can either choose wheat or sourdough. So let's assume we're choosing wheat. If we choose wheat, we can either have ham, we can have turkey, we can have steak, or we can have chicken. Or we could choose sourdough, and we can have the same thing: ham, turkey, steak, or chicken. Okay, so if we were to calculate these all out, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have a total of 8 possible outcomes: a wheat sandwich with ham, wheat sandwich with turkey, sourdough sandwich with ham, sourdough sandwich with turkey, and it goes on and on. So there are a total number of 8 in our sample space. Okay, and that tree method is one way to do it. But there's another way to do it, and that's by using the fundamental counting principle. And this says that if we take the total number of outcomes for the first event, selecting bread, we have 2 outcomes for that, and then we can multiply that by the total number of outcomes for the second event. Right? This is our first event. This is our second event. And how many outcomes do we have for our second event? That is 4. And we can multiply these together. 2 times 4 gives us 8, and that will be our sample space, or in other words, all our possible outcomes. Okay, so there are 2 ways to do it. You can do the tree method, like we did in the slide before, or you can use a fundamental counting principle, where you take the first event, take all their possible outcomes, and multiply it by the second event's possible outcomes. 2 times 4 is 8. Okay, so now in your notes, you will need to write in the very first top section, there's 1, 2, 3, fill in the blanks. All right, now we want to use a table to find the total number of possible outcomes of this situation where we have 2 events. We have one, we're going to roll a cube or a die, and then we're going to flip a coin. Okay, so we need to find the total number of possible outcomes for that. So rolling a cube, we can either have a 1, a 2, a 3, a 4, a 5, or a 6. Okay, flipping a coin, we can either have what? Heads or tails, heads or tails. Oops, heads or tails, heads or tails, and it goes on. Okay, so this table shows all our possible outcomes for the 2 events of rolling a cube and flipping a coin. Now, the other method we could use was by using our fundamental counting principle. And so we know that the number of outcomes for rolling a cube is what? 6. And the number of outcomes for flipping a coin is 2. So 6 times 2 is 12. And how many boxes do we have up here? We have 12. So both methods, listing them all out or using the fundamental counting principle, will give us the total number of possible outcomes, 12. Okay, let's look at another situation where we have outfits. Okay, and in this one, we could go ahead and create a table or a tree and then count them all up. But with this one, I think it's probably a little easier just to skip straight ahead and use the fundamental counting principle. Okay, so we have t-shirts, jeans, and shoes. Okay, we have how many pairs of jeans? 4. How many t-shirts? 1, 2, 3, 4, 5, 6, 7. And how many shoes? 1, 2, 3 pairs of shoes. Okay, so using our fundamental counting principle, it states that we can multiply all the possible outcomes of each event, and that should give us the total number of possible outcomes for using all three, right? So we have 7 t-shirts. We can multiply that by 4 pairs of jeans and multiply that by 3 pairs of shoes, which then should equal 84. So there are 84 different combinations we can create, unique combinations we can create using 7 t-shirts, 4 pairs of jeans, and 3 pairs of shoes. All right. We are going to use that information, the sample space, or, finding the possible outcomes. We're going to use that information to help us find the probability of a compound event. Okay, so remember, a compound event consists of 2 or more events, like rolling a die and flipping a coin, or choosing an outfit with jeans, t-shirts, and shoes. But in this case, we're going to look at this example and we're going to try to find the probability of rolling a number greater than 4 and flipping tails. Okay, so first of all, we know by using our fundamental counting principle or by creating a table that we are going to have how many different possible outcomes. We're going to have 12, right? Because rolling a rolling a die is 6 possible outcomes, and flipping a coin gives us 2 possible outcomes. So there's 12 possible outcomes total. Okay, that's this number here, 12. Okay, so, but now we need to know the number of favorable outcomes. So what is the probability of rolling a number greater than 4? Okay, so we need a number greater than 4 and flipping tails. And flipping tails. So how many total do we have for that? Only 2, right? We can roll a 5 and get a tail, so we can roll a 6 and get a tail. So there's only 2 favorable outcomes out of the total number of 12 that we calculated here, right? We counted them or we calculated it using our fundamental counting principle, right? So the probability of rolling a number greater than 4 and flipping tails is 1/6, which is the same as what? Yeah, we'll say it's approximately 16 2/3%. 16.6 repeating percent. All right. So, is that what is that on our likelihood scale? Probably unlikely, right? Okay. Okay, so now you need to write in your notes just about compound events, just a fill in the blank. I already put in the formula in there for you. All right, and now there are just 1, 2, 3 practice problems. Okay, first practice problem. We have the same kind of sandwich situation here, but we want to know how many different sandwiches are possible, meaning how many possible outcomes can we create using 3 types of bread and 4 types of meat. 3 types of bread, 4 types of meat. You can either do the tree and say wheat, do ham, turkey, steak, chicken, and do the same thing for the sourdough and multigrain and then count them all up. Or you can use the fundamental counting principle, which says the first event possible outcomes times the second event's possible outcomes should give you the total number of possible outcomes. So what is that? All right. Next practice problem. Here we go. This time, I'm using an old picture, but in this situation here, we actually have 4 t-shirts, 5 pairs of jeans, and 5 pairs of shoes. So how many different outfits can we make from that? Remember, the fundamental counting principle says you take the number of outcomes, possible outcomes from the first event, t-shirts, multiply it by the total number of outcomes from the second event, pair of jeans, and then you multiply that by the third event of selecting a pair of shoes from 5 different pairs of shoes. So that should tell you how many different outfits you can make, or how many possible outcomes there are in this situation. Okay, and the last practice problem. We now want to know what is the probability of rolling at most a 4 and flipping heads, right? So remember the probability of this event, I'm going to say probability of event equals, okay, what we want to achieve, at most a 4, at most a 4, and flipping heads, right? And on the bottom, we're going to have the total number of outcomes. Okay, very sloppy. So what is our total number of outcomes? So we've done this many times before, but we can do it again. We have 6 choices on a cube, and we have 2 choices on a coin. So our total number is 12. Total number of possible outcomes is 12. But now we need to find how many times we can get at most a 4 and flipping heads. So at most a 4, here's at most a 4, at most a 4, at most a 4, and flipping heads. So we can do it here, here, and here. So how many times? 3. So then what is our probability of rolling at most a 4 and flipping heads? Well, what is 3/12 equal to? Okay, and that should conclude 7.3.